Alright guys, gonna try to get these last two lessons wrapped up. The first one is finding volume using the disk method. So it's 7.2, the disk method. Wow. So what this is gonna look like, we're gonna have a region of a graph, looks like this, and pretend I have this graph that looks like that. Here's our shaded region. So think just like area, right? We do the same idea. So here's our shaded region, right? Bounded by the upper one and the x-axis. Okay. But now what we're going to do is we're actually going to take that shaded region and we're going to revolve it around the x-axis. So it's going to make this 3D figure that if you get from like a side profile shot, it's going to look like a circle like this. It's actually going to be look like an oval. If you could see, if you could hold the object, it would look kind of like a long, like almost like an egg, I guess. But this is going to be like the circle that I just drew is a side view, like from the right. So you're looking like you're down on the way, like into the hundreds on the x-axis, and you're going to be looking at the end of the egg, and you would see this circle. The reason we call it the disk method is because it is a solid figure. There is no hole. This 3D, this region right here would be completely filled in, and that's what we're looking at. Okay, so this is kind of hopefully that you can see it. If you don't see it, look it up on the internet, like Google it and just say finding volume, the disk method, and they can give you some good visualizations on how to do it. But what's happening is essentially what we're doing is we're creating little slices in this. Let's do a different color so you can see better. Different slices out of this region, and we're just making when we revolve those, we get this disk, and we have a whole bunch of those. Well, if we know how many of those we have, or if we have a whole bunch of those, we could just add all those disks together, and that'll give us the total volume of our 3D object. Okay, so we use calculus then to give us the actual area, kind of like the limits idea, right? So we can our little slices will only be approximate, but when we use calculus and antiderivatives, we can get the exact answer. So that's what we're working with. Okay. To find volume using the disk method, volume is going to equal this equation. Volume equals pi times the integral from a to b, so same thing, still need our bounds, okay, of our shaded region, okay, whatever's, so think back to like almost like area, and we're going to actually be doing top minus bottom again, okay. All of that's going to be squared, and we're doing it with respect to x. The biggest key to this is for us to have dx. We're going to be doing it across the horizontal. So I'll even draw it up here. The axis of revolution has to be horizontal. Okay. And remember, disk method, no holes, no gaps. Shaded region is directly across that. Okay. All right. So let's try a problem. Example 1. Using the disk method, find the volumes. Gotta move stuff around. Hold on. Find the volume of the region of the solid formed by revolving the region bounded by f of x equals the square root of sine of x and the x-axis, also known as y equals 0. So that'll be the key to all the problems for what we're doing in this lesson is the they will both be y equals, the equations will be y equals. Okay, since it's a trig function, I'm going to set our bounds from 0 to pi. Okay, and we're going to revolve around the x-axis. And again, this is the whole, it's got to be a horizontal line for today's lesson, revolved around the x-axis. Okay, so kind of looking at this graph, let me put that in Desmos for us. Y equals the square root of, oops, where's my functions there? Sine of x. All right, so there's my function. We're going from 0 to pi. You can probably, like if I click here, you can see that as pi. Okay, and so let's zoom in there a little bit. So I know you probably, I don't know if you can see my note, but I'll have it. It would be everything under the red arc here that's on the screen right now, and above the x-axis, that would be our region. So kind of like that egg shape like I was talking about with the introduction. So there's that. So if I draw this, this is 0, x equals 0. This is x equals pi. This is our shaded region. And we're revolving it this way. So when I do my setup, volume equals pi from 0 to pi of the top part of the shaded region. So what creates the upper bound? In this case, it's the square root of sine of x minus the bottom part, which is the x-axis, or 0, all of that squared dx. Okay. And then what you're going to do is you're just going to plug that into your calculator. So I don't have mine, or I have my work already done, so type it out. And this comes out to be 6.28 units square or cubed. Sorry, it's volume cubed. So it's pretty straightforward. The biggest thing is you can't have any holes or gaps in the disk method. That's what the washer will be for the next lesson, but I just wanted to show that to you. All right, example 2. Let's do another one. Here's your bounds. Y equals 2 minus x squared and y equals 1. And we're going to revolve around y equals 1. Okay, so sketching my graph again. Here's y equals 1. Okay, and here would be 2 minus x squared. Upside down. This. Here's our shaded region. What we need to find, though, is where do they intersect? So this is when we go back to the area thing that we did. Set your two equations equal to each other and solve. So intersection. 2 minus x squared equals 1. Subtract 2. Negative x squared equals negative 1. Divide everything by negative 1. You get x squared equals positive 1. So square root that. So x equals plus or minus 1. So x equals negative 1. X equals positive 1. We are revolving it around y equals 1. So again, kind of that egg shape-ish. Not exactly the egg shape, but it's close. So I have everything I need now. Volume equals pi times the integral from negative 1 to 1. Upper bound is 2 minus x squared minus the lower bound is 1. All of that squared dx. Okay. Remember, when you plug it in your calculator, be careful. Use your parentheses. Just be careful when you plug it in. And for this one, you should get 3.35 units cubed, since we didn't talk about what it actually was, or the dimensions. So I would say practice. The biggest thing with these, probably plugging in your calculator. They're pretty straightforward in terms of doing it. Upper, lower, left, right, yada, yada. Like the area problems, but make sure you're plugging in your calculator correctly. Practice them if you need to. Get my answers, and that should be good. All right. Thanks, guys.